Hello. Hi, everyone. Uh, today it's time for a little story. I will tell you the story of how we have built and how we are expanding our gaming studio in Allwyn Lottery Solutions. I will try to talk you through some challenges that we have faced, difficulties, solutions that we have applied, and some innovations and what we have learned along this journey. My name is Bill. I have some experience on different domains, like insurance, retail, learning platforms, betting, and most recently on gaming. My expertise is in front-end, and I currently work as a tech lead of some of our engineering teams in Allwyn Lottery Solutions. In Allwyn Lottery Solutions, we have been helping industries become more engaging to people and fun to people. We have been providing some iLottery platforms, web and mobile applications, and instant win games to our customers. Today I'm going to focus mainly on the games, which until recently, early 2022 actually, those were developed by third-party companies. But at the beginning of 2022, we decided to bring everything in-house. And we will go through what a game is and how we have succeeded in doing that later on. So first of all, when we started the gaming studio, we had some questions to answer. The first one was what would the architecture be like and what would the framework that we would choose be? And there were actually two main options that we had. It was either Pixie.js or Phaser. For those that know, those frameworks do the job just as nice. They work in similar ways, actually. And we decided to go with Pixie.js for our work. The first task then was to focus, to understand how it works, actually. So we consulted some experts. They helped us gain some confidence, and they helped us transfer some knowledge to our teams. And the first actual task, the first programming task that we had to do was to create an abstraction of the framework over a Pixie.js with the goal of making Pixie.js as invisible to our developers as possible. And then we understood that we still need Pixie.js developers with expertise, but also good JavaScript developers as well. And by the way, it was at that time that we started working on our first games. We quickly found it was not easy, and I think most of us thought that it would be easier to climb this mountain, and this is Mount Everest, by the way. So what were the main difficulties? The first difficulty that we had to face was that game development is not something popular, unlike web application and mobile application development. So we had to search for the right people to fill the right roles. Today I'm going to talk about mostly engineering and automation testing, but the same problem was apparent in all the other teams and all the other roles that we had to fill. So as you can expect, most JavaScript developers have experience mostly with the three main frameworks, React, Vue, and Angular. Not many have heard of Pixie.js, let alone have expertise with Pixie.js. And this was even more apparent in Greece, actually. By the way, this is a graph that pinpoints this. This is the downloads for the three main frameworks against Pixie.js for the last 5 years. You can see that React, of course, is very popular. You can see Vue and Angular being popular enough. And that single pixel at the bottom, this is Pixie.js. It's been quite constant along the way. And these are the numbers, actually, the latest numbers that I could find. You can see that it's totally different. The numbers are really great on the other frameworks. So we had to find ways to make everything more accessible for our people and for anyone that would join the teams, to make everything easier, actually. The first thing that we wanted to do, and we tried to do, was to document everything, such as the tools that we use and custom implementations that we have made. And we try to keep everything updated for our newcomers as well. We try to keep the processes and the ways of working constant alongside all of our teams. So either you work on a web application or in one of our teams in the company, you are familiar with what we do. And we try to follow patterns just like we would do in any other software development environment. So you can see abstractions in our project. You can see observed pattern or facade pattern and stuff like that. The first thing that we understood is that we need to make things simpler and easier. And a great example was that initially we thought that Redux would be a nice choice for the game state management. We quickly found out that it's an overkill. We just had some UI state for our components. And we could swap Redux with a small implementation using signals in order to achieve the same. So what is a game and what are the main components of a game? You can think of a game as having two main areas, actually. It's the game engine and the UI. And you can imagine the game engine as a way, it is actually a JavaScript method, let's say, for us, that creates possible game scenarios. And each of these scenarios contains symbols and an explanation of how the symbols will be presented to the user when the user plays their game. The UI, you can imagine it as something that refers to the synchronization and synchronization of animations and transitions between the screens so that the user gets a meaningful experience out of the game. And what is really important when we talk about the engine is that we need to feel secure and we need to have to make sure that the integrity is there. Because it is absolutely essential that the player is presented with the right symbols at the right time and in the correct order. You cannot really imagine a person saying that they think that they won a losing ticket and trying to claim the prize, trust me. So in order to make everything more secure and for us to make things seem like they are bulletproof, we decided to go with a test-driven development approach. I can tell you that each game has some strict sets of rules. So we create a unit test, some unit tests that validate against each of those rules. We try to break the rule. We try to see if the unit test will fail there. And we create the relevant validator methods to make sure that the unit tests follow actually validate the correct rule at its time. That's a small partial example of some of our unit tests, actually. You can quickly go through them, and you can possibly understand what rule each of those tests would test and assert. So the first one, for example, would validate that each row of the game should have all possible prizes presented and used to it. And same for the other lines as well. But this wasn't enough for us, because we also need to accompany our games with constraint tests that validate not only a single scenario, actually, but all the scenarios that we produce against the rules. Because there are some rules that cannot be tested inside the scenario. Such a rule could be, for example, that an X percentage of scenarios should contain a specific symbol, for example. So we need to gather data about the whole pool of scenarios that we create, and we need to validate that we follow these rules as well. So we try to visualize everything to make it easy for everyone to see if those rules are followed and to confirm and review it. It would be something like that. That's a small part of the report that we generate. This rule of this game says that approximately 70% of all prize games will award a multiplier. And you can see that in the graph as well, that approximately 75% really does that. The other question that we had to answer is how we're going to test the UI. So we're talking mostly about functional tests in this case, but we had to come, we came against the problem and we had to find solutions for that. The main problem is that a game is a canvas, actually, and the canvas is a black box. It's a single element for every browser, and it's difficult to interact with it because the content of the canvas is unreachable. So we had to find a way to identify elements, interact with them, and assert the actions. The idea was, can we create a DOM representation of the game? And that's how we went with it, actually. So each time we add a pixie element to our game, we add also a corresponding HTML element to an HTML layer that sits on top of the canvas. The elements have some accessibility and test properties. We have a custom test framework implemented from our side that includes methods that allow us to add those elements to the layer, and also all the methods that we need to traverse the canvas and interact with every element in the canvas. And that's how actually we solved this problem. Remember, I quickly talked about the abstraction framework that we created over Pix.js actually earlier. We wanted to make everything seem more familiar to our developers, and game development is an object-oriented word actually, so it's not something that most people are familiar with and have expertise with. So we try to make everything appear as functional as possible. And we actually implemented a way to create Pix.js elements based on configuration only. We named this solution auto-display object from our side, and it's really has been our savior. I just wanted to include these two screenshots so that you're going to see. That's the implementation of one of our elements. You can see that it's 117 lines of code here, plus 37 lines of configuration that you cannot see in this picture. But after our implementation of auto-display object, this has come down to 30 lines of code, alongside 37 lines of configuration for this one. The number just happens to be the same. The configuration is different, of course. Lastly, but not least, we have created a game development kit, actually. It's like a software development kit, as you have seen in other aspects. So this is actually an integration toolset. It provides functionality that allows us to handle parameters that the game needs to load and perform, and the implementation of any events that the game needs to communicate to any platform that it integrates with. And we have also implemented a facade that allows any team to integrate their systems with our games and vice versa. It could be existing systems or new ones. So what is the ultimate goal, actually, out of this? I had a discussion recently with a colleague, and we were discussing this debate that we had some years ago, constantly, actually, about choosing Angular or React. And we remembered that back there, we would use Angular because we felt it was more strict and secure, but we also wanted to use React because it gave us more freedom, although it could be risky. What we have found actually out here is that it's better to create a tech environment that allows people to have freedom in a way that also allows security. So we wanted to make everything independent of the libraries that we use. With this abstraction framework I mentioned before, we can possibly change Pix.js to Phaser, and probably nobody would notice. With the thorough testing that we do, we want to make sure that we can sleep at night without worrying that something might break. And that's the goal, actually. It's the best thing that we can do for our teams is to create simple and secure tech environments for all members, either they are existing members or new ones joining the team. And most importantly is to cultivate a mindset that helps us improve meaningful skills, tech skills for our colleagues, those skills that are necessary for them to grow as software engineers. Thank you a lot for attending this talk. If you have any questions, I would be happy to answer them.